Okay, section 5.4, indefinite integrals. Sometimes I call them naked integrals. They just don't have the a and the b on them. And you can see that over here on the left. And when you find the antiderivative, which is what capital F is representing, you have to put a plus c when you have an indefinite integral. So basically what we were doing in section 4.9 with finding antiderivatives and putting a plus c on the end, that is exactly what an indefinite integral is. And we'll do a couple of examples. And just to look at it side by side, a definite integral has an a and a b on it, and you get a number out of it, not a function or family of functions because of the plus c. Now, there are some things I'm just going to kind of run through, and I'm waiting for my internet to allow. It says it's trying. Okay. Oh, there we go. Now we're moving. Okay. You don't have to be aware of this, but if you are a math person, you really need to be aware of this. If you're going into something that uses math, you should be aware of this. When we solve those indefinite integrals and we get a function family, typically we just write something like this and go, yay, I solved it. Be aware that technically what you have gotten, if you have a discontinuity, especially a discontinuity due to a vertical asymptote, you technically are getting a piecewise defined function. You're not going to worry about that in this class, but I want you to be aware that technically this is going on behind the scenes. When we solve indefinite integrals without worrying about domain issues. The textbook also goes through the formula the batch of formulas that I talked you through already, but I want to show you that this is what the textbook is presenting and that these bottom two formulas we will not use in this class. They're hyperbolic trig functions. They're useful for engineering. In a calculus class, it adds on more formulas to memorize. They aren't functions that are used on the AP exam. So a lot of calculus courses don't bother with it because it just creates a lot more formulas, ultimately. Okay, let's do an example. Find the general indefinite integral. And this is pretty much what you've already done before. It's just written differently. And you're looking at the integrand is what you're focused on. You're not going to notice the behind the scenes dealings of the differential dx. But know that without it, the problem doesn't make sense. We have a subtraction sign that allows us to separately go through the integration. We have 10, a constant multiple that will then multiply by the integral of x to the fourth power. We use the power rule and integrate x to the fourth to get x to the fifth over 5. Then after the subtraction sign, we have constant multiple 2, so we keep that and multiply it by the integral of secant squared. And do you remember who that is? I already see it in chat. The integral of secant squared is tangent x. And then throw a plus c on the end. Simplify if you feel like it. But that is wrapped up and done. And I've got a second problem for us to play with. The second problem you're not going to notice right off the bat, but know that if you play around with it, you will recognize the answer to a derivative. So I'm going to give you a moment to see if you can figure out who that actually is that is already an answer to a derivative. And so far, that's a hint. Almost. There you go. With the denominator being sine squared, I'm going to look at writing that in two separate denominators whose fractions are multiplying. And then I can pick one of the numerators to be a cosine and the other one to be a 1. And now sit back and look at it. Do you recognize it? Which trig function is cosine divided by sine? Yep, cotangent. And which trig function is 1 divided by sine? Sine's reciprocal is cosecant. So when you have the pair cotangent theta times cosecant theta, who has their derivative taken, and this is the answer? There you go. There you go. And what I recommend is you want to make sure you have the derivative of tangent and secant really almost in your soul. So when I say, what's the derivative of tangent theta, you say, boom, secant squared theta. When I ask, what's the derivative of secant theta, you say, secant theta, tangent theta. So then when we go with the cos, the derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. You've got to make sure that you have those memorized. And then a plus C on the end, and you are good to go. So you're just going to be solving some indefinite integrals, which is very similar to what we did when we were in section 4.9. Now, net change theorem I've actually talked to you about already. It's the second part of the fundamental theorem of calculus, and I talked to you about what happens when we integrate velocity. And I'm going to go back to that. I want to let you know that if you're curious about what is the application for definite integrals, there are a lot of applications. A lot of applications. Your textbook goes through a list of some applications. And I will say that the AP exam likes to look at applications like this first one, where you don't have to know some science principle. You just are told, hey, if V is volume of water in a reservoir, and V prime is the rate at which water flows into the reservoir, then you are getting a net change in the amount of water in the reservoir over the time period with this definite integral. So these are the kinds of application problems that show up on the AP test. But there are a lot of applications where you need to know something in science a little bit more. But these scratch the surface of science. And you can look at those on your own time. And this is on the AP test. And you are expected to know this. So you have to know the difference between displacement and distance traveled. And I talked to you already about the fact that when velocity goes negative, we are taking away from the distance that we had already gone in the positive direction. And that's exactly what displacement is. If I move back and forth on a line, if I start here and then I go la 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 la, and then I stop, my displacement doesn't care where I've been. My displacement only cares where am I currently located compared to where I was located earlier. That's it. It is just flat out your position at time 2 minus your position at time 1 to give you your displacement, where S represents position. But if you want to know how far you actually traveled, you need to integrate speed. Now, if you have the fortune of having a calculator available on a test when you are asked to find distance traveled, you're going to want to use your calculator. I do need, though, to talk you through, if you don't have a calculator on a test, what do you need to do? Then I'm going to talk to you about how to use your graphing calculator to solve definite integrals, because that is going to be the main thing you're going to do on your graphing calculator during the AP exam. That is the biggest thing. And if you read on with all the things that are said here, I'll also add in this. If you integrate acceleration over a time period, you will get a change in your velocity over that time. But it's only going to tell you what the difference is in your velocity at time 2 from what it was at time 1. That's the only thing it's going to tell you. Okay, is it okay if I scroll away from this? And you can look it up in your textbook also, and we'll be talking about it anyway. So, an example. Set up an integral that is going to find displacement, and then set up an integral that is going to find distance traveled. For displacement, you're just integrating the velocity function itself. And if that's all you're doing, then you just get to go, ooh, yay, power rule, power rule, power rule, or constant, or yeah, whatever. Anyway, Then you plug in the 4 minus you plug in the 1, and you get a lovely number. Let's see. If I mess up on my arithmetic, make sure to tell me, because I do that sometimes. So that number, I could spend time trying to calculate it, but I don't think you want to waste your time watching me do fraction arithmetic. So there's my answer for displacement, and it's a particular number. Now, if I want to find distance traveled, I'm going to instead integrate the absolute value of velocity. And if you do not have a calculator, you have to realize that when you integrate absolute value, you have to think of absolute value as a piecewise defined function. It is either the positive value of that function or it is the negative value of that function. And that depends on whether f of x itself is positive or negative. So if f of x is a positive value, but you've got to go through and figure out what are the x's that make it positive and what are the x's that make it negative. And one of them gets the or equal to sign. Usually it goes with the positive, but it doesn't really matter either way. So what you need to do is you need to look at when is t squared minus t minus 6 equal to 0. And then once you figure out what makes it equal 0, are any of those within the interval between 1 and 4? And I just realized I wrote t squared twice. There we go. You got it. So the full solution to the equation is 3 and negative 2, but only 3 is within that interval. So again, if you don't have a calculator, you have to write this as 2 separate integrals. And with each integral, you have to stop and ask yourself if you're working with the function in the absolute values or the opposite sign of the function in the absolute values. So if my t is between 1 and 3, is this quadratic positive or negative? If t is between 1 and 3, is that quadratic positive or negative? There we go, negative. So that means that I need to change the sign on this function, which I can just go, I like to distribute my negative so that I don't neglect it somewhere. So I've got to negate that whole thing. Then I'm going to add to that the integral that goes from 3 to 4. And when I'm between 3 and 4, is that quadratic positive or negative? So that means that I'm just going to write the function as is. Then I'm going to integrate. Do you see how much work this is? And do you feel like begging for a calculator now? Yes. So I'm going to talk you through what you need to be able to do with your calculator. And yeah, I'm going to clear that out. Okay, so I'm going to show you a couple of different ways to use your calculator. And if you later get a calculator, you may want to rewatch this video and see how to do the calculator. And I need to be able to see myself and what I'm doing. Okay. So if you're on the home menu, if you're on just the regular home menu, which you can get to by doing second and then quit, can take you there. The key phrase is Math 9. You have a math button right here. Push that button and then the number 9, because the definite integral is the 9th thing down the menu. So math, and then just go straight to 9. Some of you are going to see this. Others of you are going to see the FN int. And I just realized that you guys are not going to be able to see me pointing to things in this video. You know what? Here's what I'm going to do. I'm going to stop the recording